All right, so let's talk cartilage. Whenever I look at cartilage on a slide, I always think of deviled eggs sitting in red jello, whether it's strawberry jello, cherry jello, whatever, but that's what I think of. And kind of like with muscle, all right, you have that same two look really, really similar, these two right here, versus one that looks like the redheaded stepchild that looks like it doesn't match in the family at all. So again, when you're looking at the cartilage slides, the cartilage histology, it's a good idea to look at it side by side by side. Okay, that way you can really see the differences. So hyaline cartilage, this one right here. Hyaline cartilage looks like deviled eggs in red jello, but the red jello is completely smooth. Notice that there are no squigglies in it, there's no nothing in it. Hyaline cartilage has that kind of smooth jello look, whereas fibrocartilage, if you look at fibrocartilage, you can see it almost looks like really fine cat hairs in the jello. It's not smooth like what you see over here with the hyaline cartilage. So fibrocartilage has fibers. Now elastic cartilage, this little dude here, to me has always resembled deviled eggs in a purple fur coat. You've got tons of fibers. And one of the big differences is that these are elastic fibers and not collagen fibers like what you find in fibrocartilage. So, as far as the type of tissue that all three of these are going to be connective tissue. Again, you got four options. These are going to be connective tissue. If I ask you to identify the slide, this one would be hyaline cartilage, this one would be fibrocartilage, this one would be elastic cartilage. So let's go through them individually. Hyaline cartilage. Tissue. Type of tissue. Connective tissue. Right? ID the slide. This is hyaline cartilage. Hyaline cartilage. How do I know that? Cartilage. Okay, I can't spell. Sorry. Look at the jello. Are there any stringies in the jello? No. And I do have deviled eggs sitting in jello. Where would you find it? Hyaline cartilage is kind of the most abundant. You find it at the ends of bones. If you've ever had a turkey leg or a chicken leg, that chunk of cartilage that comes off the end of the bone, that's actually hyaline cartilage. The cartilage in your nose is hyaline cartilage. The cartilage in your ribs is hyaline cartilage. Hyaline cartilage has the ability to give structure, but it's flexible structure. I can go up and squish your nose and it's not like it stays that way. It'll pop back, but it does have the ability to squish down. You can't really do that with the skull. You can't really just squish the skull and hope it pops out and hope for the best. With cartilage, though, the rubbery consistency allows you to do that. So let's talk about the parts and pieces. So these cells that you see are actually chondrocytes. Remember, chondro meant cartilage, and cyte meant cell. So literally, chondrocyte is a cartilage cell. All of these things that you see with nuclei are cartilage cells. The lacuna. In Spanish, what does lacuna mean? It means cradle, right? Or crib. The thing about both bone and cartilage is that the matrix that those cells are sitting in is either going to be rubbery hard or it's going to be concrete hard. So you can't get the cells to dig through that. It would be like me saying, okay, there's a sheet of concrete, go dig through that with your bare hands. Would you be able to do it? Probably not. So with that in mind, you kind of have to make a space for a cell to sit in and then build around that cell. That space is called the lacuna. Now, here in this specific picture, you'll notice there's a space here. I mean, it looks like there should be a cell there, but there's no nucleus. So there's no cell actually sitting in that space. So all you have is the cradle or the crib. The perichondrium. Peri means around. Chondro means cartilage, right? So the perichondrium is a type of connective tissue that surrounds the cartilage. It actually is, I guess you could think of it like equivalent to having pants on the outside of your leg, except in this case, it's around cartilage. Pretty much any hyaline cartilage or cartilage that you have in your body, perichondrium surrounds it. And we'll find out why when we get to the skeletal system in lecture. So fibrocartilage. Again, what kind of tissue is it? Well, it's connective tissue. ID the slide. Well, see all the little hairs? Look at all those hairs. This is definitely going to be fibrocartilage. I've got deviled eggs in pink jello, but I've also got all of these hairs inside the jello. Now, where would you find it? So fibrocartilage, its function isn't just structure. It actually acts like a shock absorber. In other words, you can put a lot of pressure on it and it'll bounce back up again. So, you know your spinal column, those bones along your spinal cord, the vertebra? In between those bones, you have these little patties of fibrocartilage. And the reason that you've got these little patties of fibrocartilage is so that if you jump up on your feet and then land on your feet, you don't have this bone clacking into this bone. Instead, you've got this little patty of fibrocartilage that acts kind of like a tennis ball. It's a shock absorber. The bones hit, or well, the bones compress, but there's this nice little rubber pad in between them that prevents the bone from actually whacking into each other. So just like before, you can see nuclei here, right? So those are going to be the chondrocytes. Technically, fibrocartilage is still cartilage, so we still call them chondrocytes. You can see the collagen fibers. These little fibers here are going to be the collagen fibers. Now, with elastic cartilage, what kind of tissue is it? I know you're getting sick of it, me asking you, but it's a way to kind of remind you, you need to know that. Connective tissue. Identify the slide. Well, it's elastic cartilage. Where would you find elastic cartilage? The ear. Think about your ear for a second. I can yank on your earlobe and it bounces back to where it was. I can squish your ear or manipulate your ear and it'll always bounce back to where it was, right? Somebody can grab your ear and go, come here. And yeah, it stretches a little bit, but it's not like it stays there. It bounces back. Again, you can see nuclei here. So we've got chondrocytes. You can see spaces that don't have any nuclei. So you've got the lacuna. And you can see all of these purple fibers. These are all elastic fibers. All of this furriness that you see, those are all elastic fibers. Bone. What kind of tissue is it? It's connective tissue. Identify the slide. Bone. Just like with adipose, the visualization of bone on a slide is very distinctive. You cannot mistake it for anything else because it looks like rings. It looks like rings that go around like this. Do not say tree. I know you want to, but don't. And there's a really good reason why I say that, because people will put that on the test and I don't want you to do that. So, where would you find bone? Don't say in the bones. but maybe the skull, the vertebra, the femur, the tibia. You can name any bone in the body, and technically you're right. So this looks like a bullseye, right? You've got kind of the center circle, and then you've got these concentric rings around it. Each one of these concentric rings is called a concentric lamella. So each one of these rings, all the way around, this entire thing, the entire lifesaver, is a concentric lamella. Okay? If cartilage was so hard that the cells couldn't burrow through it, bone is even worse. So again, you've got these spaces where the cells are going to be put called lacuna, the cradles. And finally, dead center right here, you've got something called the central canal. Because your bone is as dense and hard as it is, you can't put things in later. So you actually kind of have to make the pathways for arteries, veins, and nerves ahead of time. This central canal is actually going to be one of the places where the blood supply goes in and dirty blood goes out through another blood vessel, and nerves actually travel through these central canals. Finally, this whole thing, this whole unit is called an osteon. Now, we've talked about chondro and what chondro means. Osteo means bone. So when you hear about osteoporosis on the TV, that's bone. That's what they're talking about, is bone. Finally, we have the blood. The blood is the only liquid tissue that we have. So what kind of tissue is it? You have 4 options: epithelial, nervous, muscular, or connective. So it's connective tissue. Identify the slide. It's the blood. You can always tell blood because of these little cells right here. That's an awful color to use. Hang on. Because of these little cells right here. These are the red blood cells. Red blood cells don't have any nuclei. Notice there's no big purple blob in the middle of them. So, excuse me, you've got those cells, and when you see those, you know that this is blood. If you see little cells with no nuclei, blood. Where would you find it? Don't say throughout the body, because that isn't right. Your blood doesn't swish around your body like your body is an empty cavity. It doesn't work that way. If that is happening, you're bleeding internally and you need to get to an emergency room and have surgery. So where do you find it? Well, it's either in the heart or in the blood vessels. That's where you find it. You have a closed system for your blood to follow. You have a highway system in your body that your blood follows. It doesn't just willy-nilly leak out everywhere, because if it did that, you would bleed to death. So let's look at the parts and pieces of the blood. So as I pointed out earlier, these pink cells here are going to be the red blood cells. If you see anything that has a nucleus, a dark purple nucleus, these are automatically going to be white blood cells. Red blood cells have no nuclei. White blood cells do. You also have the fluid that the cells are floating inside of. That is the plasma. So if I point and there's nothing there on a blood cell slide, I'm pointing to the fluid. And then finally, we've got these little dudes here. These are platelets. Platelets help to clot your blood so that you don't bleed out. You can see there's another one over here on the right-hand side. There are a couple up here on the upper right-hand side. They're smaller than cells because they're not really a cell. They're a chunk of a cell, but they do help us so that we don't bleed to death. And those are your histology slides. And yes, you do need to know those for the practical. I will upload all of my histology slides as soon as I get an opportunity to do that.